Welcome to this lecture. We will discuss a question from previous year GATE question paper of chemical engineering. This is also related to somewhat related to first order systems, transfer functions, Laplace transform. The question is this. This is question number 58 from chemical engineering paper of year 2006. A process is perturbed by a sinusoidal input u of t equal to a sine omega t. The resulting process output is y of s equal to k a omega by tau s plus 1 into s square plus omega square. So this is the output given in terms of Laplace transform variable y of s. If y0 equal to 0, the 0 means initial deviation. The differential equation representing the process is this, one of these. So you have to find out the right answer. Well, how do we do this? Take a pen and paper and find y of s for each one of these. How do you find y of s for each one of these? So from differential equation to get transfer function, to take Laplace transform, then substitute this u of s and get y of s. You know y of s equal to gs, g of s, transfer function. G is transfer function into u of s. So find the transfer function of each one of the four and then find out which suits this. But that cannot be the way with paper and pen doing all taking Laplace transform of all four. It will take a long time. So we have to do quicker than that. If your knowledge about transfer function, Laplace transform and differential equation are very strong, very good, then you will be able to find out the answer without any paper or pen, without writing up anything, without writing anything. So let's see how we find out the answer without writing anything. Now y of s, as I told you, it is g of s into u of s. So ut is this, right? This is ut. So what will be u of s? A omega by s square plus omega square. Here it is. So this is u of s, a omega by s square plus omega square is u of s. So the remaining term k by tau s plus 1 is the transfer function g of s. It's a simple first order function. So if you are done the derivation of 2 or 3 first order systems which we have discussed in our lecture series, then you will be able to find out. Right now you can tell me which one suits this. Now this is what? This is it, u of s, right? A omega by s square plus omega square is u of s. So a is already here. A comes from this. A comes from this. So there cannot be any a in the given equation. Since a is already there and this, which comes from this, a comes from the u of s. So a cannot be from the differential equation. So these two are wrong. These two are wrong options, right? So these two are wrong options, this b and d, because a cannot be there in the equation. So you are left with only these two. Now we have to get tau into s. So which one will give us tau s? If you consider this option C, this will be what? If you take Laplace transform, this will be s into y of s. That is, coefficient of s has tau. So this term, it is this term, and Laplace transform is going to give me s into y of s with coefficient tau. And this is y of s. So if you take y of s common, this is going to be tau into s plus 1. So only this term is going to give me tau s into y of s. The tau is there. This transform of this is s into y of s multiplied by tau. So this will be y of s. So when you take Laplace transform of this, you will get tau s plus 1. So the option is, correct option for this. So this is tau s plus 1 here. So the correct option for this is option C. Option C is the correct answer. Option C is the correct answer. So if you want, you can check this A also for just for additional information for you. If you try for option A, you will get what S plus tau you will get. If you try for option A, instead of tau S plus 1, you will get here S plus tau here. So option C is the correct answer. So it is important not only to know the right answer, but you should know, more important is you should know how to solve quickly, the method of solution. So that is more important than the actual solution. Solution is important, you should know the correct solution, but how quickly you are able to do solve the equation, solve the problem. That matters in the exams of the type GATE. Well, we'll see more such questions, more such problems solved in the coming lectures. See you.